So before you watch this lesson video, you've already learned how to solve a system of equations by graphing, and that's going to be what we use to check all of our work today and next class when we learn two other ways to solve systems. The way that we're going to learn to solve a system today is called solving a system by substitution. Now, substitution is really cool. Just like a substitute teacher would replace a teacher in school, you're going to be replacing or plugging in a different expression using parentheses to replace or plug in a value that will help you solve the system. When we have two types of letters, we can't solve for one value, but if we only have x's or we only have y's, we're going to be able to solve for a value of x. Now, that being said, we will need to thoroughly understand what the word substitute means. But like I said, substitute just means to plug in. So right here, and just a little quick review, we want to substitute or plug in an 8 everywhere we see an x in this equation. But we're going to do that using parentheses. So here's the original equation, and when I see the x, I'm going to plug in that 8, or substitute in the 8. That's what the value of x is. Again, anywhere I see that x, I'm going to plug in an 8. That would be substituting in the value of x into the equation, similar to how we did function notation and evaluating functions. We're also going to be substituting or plugging in expressions for letters. Do you see how this expression stands for y? We're saying y is 4 plus x. That means that in this equation of 2x minus 4y, I can substitute or plug in that expression 4 plus x for y. Like you see how a second ago it said y, and now I plugged in the value for y. So we're going to be substituting or plugging in expressions and values into different equations to solve a system, to figure out the coordinate x comma y that makes both equations true. Now on your notes, there is a fully worked out example. It is color-coded on your screen here. It is probably not color-coded on what you printed out. So I highly recommend using colored pencils, maybe a highlighter, and highlighting along with me as I walk through the steps for you. So if we are asked to solve a system by substitution, remember that solving a system means that we're looking for the x comma y that makes both equations true, or we're looking for where the two equations meet on a graph, their point of intersection. But if we're not going to graph this, we're going to solve them by substitution. The first step would be to isolate a variable. Isolate means to make by itself. So sometimes you're going to need to solve an equation for x or solve an equation for y. Rearrange the equation so that only one variable is by itself, like we've done here. We solved for y. We took the first equation, we moved things around so that it says y equals x plus 3. You know how to solve for y. These are the same steps that you've been doing for a while. Drag the 2x to the other side, cross the line, change the sign, divide by -2 to each and every piece of this equation, and then we have an isolated equation. Step 2 is to substitute the isolated expression into the other equation. Okay, I'm going to do that part in green. Substitute the isolated expression. So we are going to take what we've just isolated, and we're going to plug it into the other equation where that isolated value is. So I'm plugging in x plus 3 in the equation where y belonged. See how we substitute that in? We're going to plug it in parentheses. Okay, the next step says to solve the equation like normal. So normally when we have a single variable equation, we would use distribution. 3 times x is 3x, and 3 times 3 is 9. And then either use inverse operations or the box method to solve for a value of x. We add the numbers across the top, we divide by the coefficient of the x, and we would find out that x is equal to 1. When we were solving straight up equations, we were done, but remember, this is a system, so we don't just need one part of the solution, we're going to need both parts of the solution. So once I've done the purple step of solving an equation like normal, we're going to substitute that value back into the isolated equation, or the red equation that's on your screen. If you see, the red equation from the top is y equals x plus 3. but I'm going to plug in that -1 that I got. When I plug in the -1 for the x, because that's what the value of x is, I can just I can add -1 plus 3, and I'm going to get that the value of y is equal to 2. Which means now I both have an x value and I have a y value. When I have an x value and a y value, I can put those into a coordinate pair and say that that is the solution to my system. If I wanted to check my work, all I would need to do is graph both equations and guarantee that this coordinate of 1, 2 is exactly where the two lines meet, because that is the graphical solution. So we can always check our work with what we learned last time. For good measure, let's just double check and make sure we understand these steps. So again, if I'm asked for the solution to a system, I'm going to need to isolate a variable, and that means make sure one of the equations either says y equals in an expression or x equals in an expression. Sometimes you don't have to do the red step. But then you're going to take this expression and plug it into the other equation, exactly where it belongs. Okay? At that point, your equation only has one type of variable, either just x's or just y's. When your equation has only one type of variable, you can solve like normal using the box method or inverse operations. You should end up with x equal a number or y equal a number. After that, you're halfway finished. The last step is to substitute that number of x into the isolated equation, which in our case we wrote in red up here. Okay, so we're going to take y equals x plus 3, and we're going to put in the value of x, which was -1. Then it's just a simple computation problem, so that y is equal to 2, and I know that my coordinate is x, y, -1, 2. Let's see another example before I have you guys try one on your own, all right? Let's check out the one on the inside here. It says, solve the following system by substitution. Again, we know that solving a system means that we're looking for the x, y that makes both equations true. If we're going to do this by substitution, the first step is to find an isolated variable. Do you notice that this equation right here is already isolated for x? Fantastic. That's what we want. What we're going to do now is we're going to take that isolated expression, the 16 minus 4y, and we're going to plug it into the other equation. Here's the other equation. 3x plus 4y equal to 8. I'm going to take this green circled equation from the red one, and I'm going to plug it into x. Why would I plug it into x and not y? Yeah, because this says x equals. So if this is what x is, I'm going to put it exactly where x belongs. Great, so here I go. 3 and then x, but x is 16 minus 4y. Then we're going to finish out writing the equation. Do you notice that now your equation only has one type of letter in it? It only has y's. If that's the case, then we can solve like normal. We're going to distribute and then set up some boxes so that we can solve using the box method. If you like inverse operations better than the box method, then you can ignore my box method. But we're going to solve using the box method on the notes here. We set up our boxes. There are 2 terms with y's and 2 terms without. So we start organizing our information, taking that 48 to the other side. Oop, cross the line, change the sign. We're going to add together the things on the top. So -12y plus 4y is -8y. And -48 plus 8 is -40. Divide by the coefficient of y, divide by the coefficient of y. We would see that y is equal to 5. That is the first half of this problem. We did it. Congratulations. Okay, what happens next, once we have solved like normal, we now have a value for y. We've solved like normal. That means we can take the red equation from the top, 6x equal to 16 minus 4y, And instead of writing 16 minus 4y, we can say that x is equal to 16 minus 4 times 5. Do you see how this y now gets plugged into the y of the original equation? Now it's a simple computation. You throw 16 minus 4 parentheses 5 into a calculator, or you do it in your brain, and you would find out that x is equal to negative 4. That, my friends, is the second half of this solution. All that's left is to write it as a coordinate pair. But remember, coordinate pairs are always x comma y. So my coordinate pair should be negative 4 comma 5, because the x goes first in a coordinate pair and the y goes second. And I got both of those pieces of my coordinate from different parts of the steps of solving a system by substitution. If I wanted to double check and make sure that this was correct, obviously I could graph both of these equations and ensure that the coordinate negative 4 comma 5 is where the graph has an intersection point, just like we did last class. So these steps are a little bit lengthy, but it's just different parts of math that we've already done. We've already spent time isolating equations or solving for y. We've spent time solving single variable equations with the box method. We understand what it means to evaluate or plug in, just like function notation. So each part of this we've practiced isolated, but now we're putting it all together to a really cool way to solve a system. This last one is for you. I will give you one hint that I want you to follow. There are so many ways you could isolate a variable, the red step, for this problem. I highly suggest taking the second equation and solving for y. That's going to be something that sounds simple and easy for you guys since we've already solved for y a lot. So I want you to start there. Pause the video, give it a shot. Hopefully you paused the video so you could try this problem on your own. We did need to isolate for our red equation, or we needed to isolate for a variable, which means we were just going to solve one of these equations for y or x. It does not matter. You get to choose. It is simpler to solve equations for letters that have a coefficient of positive 1, but you can do what you want. We're going to solve for y here, and then we're going to take that isolated expression and we're going to plug it in to the other equation. We plug that in where it belongs, so we plugged in or substituted in that expression for y. At this point, we have a single variable equation, so we distribute, and we use the box method to solve for a value of x. Once we have that value of x, though, all we're going to need to do is plug the value of x into our isolated or red equation. We knew that x is equal to 5, so when I can write down the red equation, I can then plug in or substitute in that value of 5 into the equation. From this step, you just throw this into a calculator and compute negative times 5 plus 7, so negative 5 plus 7, and negative 5 plus 7 is 2. Now, here's where a lot of students get messed up a little bit. Which one, I'm going to write down two options for our solution. Which one is the correct solution? Is it 5 comma 2 or 2 comma 5? Hopefully you notice that because coordinates are always written as x comma y, means that we need not the second one of 2 comma 5, but we actually need to write it with the x value coming first. We got that the x value is 5, so 5 goes first in my parentheses. We got that the y value is 2, that means 2 goes second in my parentheses. This is what we think the solution to the system is. But, as always, you can throw these equations into a graphing calculator and ensure that that is exactly where the two graphs or the two equations meet, their point of intersection. That's a great way to check your work here. All right, so today we learned how to solve a system by substitution. It does have a lot of math associated with it, but is all math we've practiced individually. If you can solve equations for y, solve single variable equations using the box method, and evaluate, all you have to do is those three things in that order, and you will find the solution to your system. As always, check your work with Desmos, and let's see you in class to solve some systems by substitution.